For lesson 9-5, I decided to do number 4, which is n squared plus 26n plus c, and it said to find the value of c such that each expression is a perfect trinomial. So this being a perfect trinomial, we have to find c. So I got c is equal to 26 over 2 squared. Solving this, I get c is equal to 13 squared, and squaring 13, I get c is equal to 169. For lesson 9-6, I chose to do number 3, which is 2y squared plus 12y plus 10 equals 0, and it's said to use the quadratic formula to solve each equation. So dividing each term by 2, making the first term equal to 1, I get y squared plus 6y plus 5 equals 0. And using the quadratic formula of y is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, I substitute each term, this being a, b, and c. So you get y is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 5 over 2 times 1. Evaluating that, you get y is equal to negative 6 plus or minus square root of 36 minus 20 over 2. Going over here, you get y is equal to negative 6 plus or minus the square root of 16 over 2. And converting that, finding the square root of 16, you get y is equal to negative 6 plus or minus 4 over 2. And setting up your two solutions, you get y is equal to negative 6 minus 4 over 2, and y is equal to negative 6 plus 4 over 2. Solving that, you get y is equal to negative 1 or y equals negative 5. For lesson 9-7, I chose to do number 7, which gave us a table of graph x and y with the numbers 0, 1, 2, 3, 4, and 0, negative 2, negative 8, negative 18, and negative 32. And we were told to write to which type of function best models the data, use differences or ratios. So seeing how this one, everything, it pluses 1, while this one, you have it's different, and then you get to the same one. So the x values have common differences. The first difference of the y values aren't constant, and the second difference of y values are constant, making this a quadratic function. So for lesson 9-8, I chose to do number 11, which is y equals x squared minus 3x minus 27, and we were told to solve each system using substitution. So I got x minus 6 equals x squared minus 3x minus 27. Subtracting x minus 6 on both sides, this cancels out, giving us 0 is equal to x squared minus 4x plus 21. Going here, rewriting that, and finding two binomials that if you multiply these two, you get 21, but if you add them, you get negative 4. So I got x 0 is equal to x plus 3 times x minus 7. Setting these two binomials to 0, you get x is equal to negative 3 or x is equal to 7. For lesson 10-1, I did number 1, and it gave me a is equal to 16 and b is equal to 12, and I was told to find the missing length. So using this equation, a squared plus b squared equals c squared, I substituted a and b into the equation, giving me 16 squared plus 12 squared equals c squared. Converting those two, I get 256 plus 144 equals c squared, and 256 plus 144 is equal to 400 equals c squared. Squaring both of these to take out this square and to isolate c, you get c is approximately 20. For lesson 10-2, I decided to do 21, which is and we were told to simplify the radical expression, and it gave us the square root of 36 over 25. So first we're gonna separate it into two different square roots. So the square root of 36 over the square root of 25. Writing it in exponential form, you get the square root of 6 squared over the square root of 5 squared, and converting that, you get 6 over 5. For lesson 10-3, I chose to do number 3, and it gave me 9 square root of 10 minus 8 square root of 10, and we were told to evaluate. So you just get since you have the same square roots, you can just take the number out here and subtract it and keep the same square root. So you get 9 minus 8, which is 1, square root of 10, which is the same as saying the square root of 10.